Hello, and welcome to the second lecture in our immune disorder lecture series. And here we will talk about hypersensitivities. Okay, and hypersensitivities are categorized type 1, it's the Roman numeral, type 2, type 3, and type 4. Okay, and the way I kind of like to imagine them is that they are like least severe to most severe. Okay, and then type 4 is kind of like its own class. Okay, and then more severe. Okay, and so we've already kind of seen uh, that the immunoglobulins are important for immune response and adaptive immunity, and how immunoglobulins are essentially the antibodies that we know and love. And so this kind of goes back to adaptive immunity a lot, and this is why it's included in this unit rather than the next set of unit where we get into all of the bacteria. Okay, and so what did we already learn? We learned gamed. Okay, we learned that we have 5 main immunoglobulins. Okay, and we learned that IgE is for allergies. Okay, allergies. Okay, so IgE. Okay, and then we learned that G and M were the other big main players. Okay, they were the main players in the primary and secondary immune response. They're the highest by concentration overall. They are really the main players in our immune responses. Okay, so why am I highlighting allergies? Well, those are our type 1 hypersensitivities. They are categorized by allergens or particles that elicit an immune response that are actually harmless. They don't cause disease and that it gets you sick. They can just react with a antibody or they won't. And they typically react with IgE. Okay, and so IgE is associated with allergies and type 1 hypersensitivities. Okay, and these ones are called immediate. Okay, so here's some allergens and some plants. Here is a skin rash. Okay, uh, characterized by a skin allergy. Okay, and then we also have peanut allergies, which are, of course, more and more prevalent. And peanuts, they don't serve peanuts on planes anymore. Okay, because they can provoke severe reactions. Okay, and so remember we kind of learned about allergies and inflammation, and that inflammation and allergies are usually caused by histamines. Okay, well, we can also use serotonin and heparin, and these are in the components of the granules. Okay, but typically, if you just want to remember histamine as the allergic reaction messenger, that would be okay. So here we can see the actual reaction where allergens mimic being a allergen. Okay, well, mimic being an antigen. Okay, they are not going to cause disease, but they're being picked up. Okay, and they will be presented on our antigen or producing cells, a dendritic cell, a B cell, right? Okay, so the APC will present it to a helper T cell. Okay, the helper T cell will give it to a B cell, which will proliferate into a plasma cell that secretes IgE. Okay, and this all sounds familiar. This sounds very much like humoral defense in our adaptive immunity videos. So if this isn't looking familiar, you should go back to that and check that out again. Okay, but we've released IgEs against those allergens. Okay, So, hey, next time we see that allergen, we'll be ready, okay? And so that is now sensitized, okay? And we have some basophils and some mast cells with those IgEs ready to go, primed against that allergen, okay? That was the first time. Now we're ready. Next time we get subsequently exposed to that allergen, we are ready. We don't have to wait for it to get presented to us. Our basophils and mast cells will detect it, and they will release histamines, kinins, proteases, all the other kind of good stuff to elicit an inflammatory response. Okay, and now you have an allergic reaction. Okay, if you're going to inflame your airway, you're going to cause anaphylaxis where you can't breathe, right? And so we have different types of inflammation that this can elicit, and one of them is anaphylaxis. Okay, you can just get asthma, okay, where the constriction of the bronchi, okay. You can get hay fever, okay, and hay fever actually goes kind of to the hygiene hypothesis that I'll explain in just a second. And you can also get hives, okay? Hives and anaphylaxis, right, are there too, but anaphylaxis is definitely the lethal version of just hives. Okay, so hay fever and the hygiene hypothesis. Okay, it's speculated that we're getting more and more allergens because of our sanitariness and because of the infrequent amount that we encounter allergens. Okay, and it's become a hypothesis because a scientist, developed the hypothesis based on that firstborn children seem to have a lot more allergies than secondborn and thirdborn and fourthborn and even fifthborn, and even in these larger families, the youngest one seems to have no allergies versus the older one. Okay, and backed up by many different anecdotal sources, right? Remember, not too many people have 8 kids, and so, but as you go on and on and on, you can see that the uh, pressure to keep the firstborn clean and organized is there, whereas by the time you're on your 8th child, uh, you know, everything's against the wall, everybody's doing their own thing, and the kids are encountering more allergens. Okay, and so yeah, and so the hygiene hypothesis developed that kids didn't get as much hay fever if they were in these larger families and they were younger. Okay, and hay fever we can see inhalation of just mold and pollen, runny nose, watery eyes, and sneezing. Okay, that's not as common in these younger kids. Okay, so that is type 1 hypersensitivities, or the immediate hypersensitivities. We also have cytotoxic hypersensitivities, or type 2 hypersensitivities. Okay, and these are going to be both kind of categorized by blood, hemolytic transfusion reactions, hemolytic disease of the newborn. Okay, so those both kind of involve blood, hemolytic blood destruction. Okay, these are going to involve either IgM or IgG antibodies. Okay, if you're going to get a disease of the newborn, of course, right, we're going to assume it's crossing the placenta or it's about the fetus. Okay, and if we're going to get a transfusion reaction, right, it's going to be when we get a transfusion of blood. Okay. Speaking of which, we can talk about blood types and the different types of blood groups that we have. And we can see that we have type A, B, type AB, and type O. Okay, you may have seen this in anatomy class, but we can definitely see that if you have the A antigens, right, you wouldn't have an A antibody. You would have a B antibody. Okay? Otherwise, you would cause this reaction that we're going to be talking about. Okay? And so, if you have the B antigen, you would have the anti-A. Okay? And so, if you're type B, you can't receive type A. You can only receive type B or type O, which doesn't have any antigens. Okay? So, but that is how these reactions and how these blood types work. Okay? If you are type O, you can't receive from either A or B because it will bind agglutinate and cause these clumps in your blood. Okay? So A has an A antigen, B has a B antigen, AB has both antigens, and O for 0 has none. Okay? And so you can kind of see now that if you encounter B blood and you have type A, you will cause this reaction, right? And all of your blood will start to bind and clump together. And we saw what happens when that happens, right? These activate the complement cascade, causing hemolysis and the release of hemoglobin. Okay? And if you release hemoglobin, then you're going to get it in your kidneys and in your urine, and you can detect it. So that would be a transfusion reaction with a bad blood donor, and that's why blood typing is so important. You can also get hemolytic disease of the newborn, where instead of A, B, O, you may have heard you're O positive or B negative. Well, that's referring to this RH group. And if the RH antibodies and antigens don't match up, the same kind of thing happens. Okay, and you would encounter a disease of the newborn with this because the antibodies and antigens will react and nothing good will happen from that. Next we have type 3 hypersensitivities or immune complex mediated. Okay, these are going to involve both IgG and IgM. Okay, and so when the IgG encounters these antigens, it's going to make an immune complex. The immune complex elicits the complement system. Okay, that complement system is making its way back here again too. Remember, we learned that in innate immunity. It was also part of our case study. Okay, and this is what happens if your cascade system runs away. Okay, you will get inflammation and actually start to destroy your cells. Okay, and this is the lupus hypersensitivity that we saw. This is actually what was happening with our airline pilot Carrie. Okay, and so this would be the most severe form. Okay, and then, as I said, type 1 can cause death, but most of them are just simple allergies. Type 2 is kind of a little bit more severe, and type 3 is the most severe. Type 4 does not involve antibodies at all, and type 4 is associated with like poison ivy and other kinds of things like that. They kind of mimic allergens, but actually they're called haptens. Okay, and so the haptens are what causes type 4 hypersensitivities. Okay, and they cause the release of cytokines and formation of lesions, and it's kind of like an allergy actually, but it's just a different form. Okay, and it can cause severe tissue if it's long enough. Okay, so it's haptens, instead of just allergens. And so we have some type 4 hypersensitivities: contact dermatitis, chronic asthma, and contact dermatitis, just like poison ivy. Okay, it also does tissue transplant rejection, and this is where grafting comes into play, and you can have problems with grafting as well. All right, and of course, you might have heard that if you get occupational exposed to dust, mold, allergens, mice, cheese, chickens, all the good stuff, you're just constantly encountering them, you will develop a hypersensitivity response or an allergy to it. All right, and so here you can see all the stuff that we need to know for our hypersensitivities. Type 1, IgE, type 2, IgG or IgM, type 3, IgG and M, and type 4, no immunoglobulin, just T cells. Okay. You can also see the examples of them: hypersensitivities, anaphylaxis, hemolytic disease, lupus, rheumatoid arthritis. Okay. And over here in type 4, you can get a lot also, well, even up to multiple sclerosis, but it just doesn't involve the IgGs or any immunoglobulins. And typically, to treat these hypersensitivities, you can get desensitized over time, and you can have an epinephrine injection if you got a bee sting. You can take antihistamines or anti-inflammatory drugs. Antihistamines will help with daily allergies and so forth. And you can even just, prevent further exposure. Don't go in the sun so much. Don't go near all those chickens. Don't go near all those mice, and so on and so forth. All right, so those are our hypersensitivities. We'll get into the autoimmune disorders in the next video.